for part 3 of the PID loops. In this section we're going to be doing the tuning function of the PID loops. I'm Mira from DRA Global, and let's get into it. So I'm going to go back to my PID loop here, and I'm going to go to configuration. So on the configuration page, I've got a few settings for tuning that we can get our loop stable. It's not going to work exactly now because we're in the simulation mode, but I'm going to run through the parameters with you. So here I've got my output settings, my minimum and my maximum for your basic clipping and clamping. So because this is a VSD, I'm actually going to put in 40% there as a limit on my VSD. And then I've got my set point settings. So let's say, for example, I don't want my operators to let the set point go below 35%. I don't want it to go above 60%. Then I can actually enable that here if I want to clip and clamp things. And also, depending on the type of control that you've got, if it's got a sporadic value, I can actually also add a deadband here to filter out some noise in the PID loop itself. Then here at the loop section, I've got my different control variables, parameters, my gain, my integral, and my derivative. So at the bottom, you've also got a selection of them. If you want a standard PI controller, you would tick the first two. If you want a full PID, you would select all three of them. So let's say for this argument, we actually want to select all three. So because this is level control, I'm actually going to give it a negative gain because I want it to actually go on the root. I'm going to start off my tuning with, let's say, integral of 2, and I'm going to give it a very minor derivative of 0.1. With a level control, you would unlikely use your derivative, but let's just keep it in for this example. So with that being in now, you would typically, if you plant, your variable will start to go up and down as your plant is running. And there I can see already with my tuning parameters that my signal is going off, my control variable is going off fairly slowly. And let's say I don't take it up a notch. Here it's actually going to go down, and if I go, you can see that it's really attempting to control it. Now I've put the PV quite close to that, and because it's actually within a deadband, it's actually going to keep it static in that position. As you can see here from the trend, we've actually played with it a little bit. If it's a highly advanced loop that you want to tune, and from the scaler it might be a little bit difficult and you want additional parameters to actually play with, you can actually come into the PID parameters in the DB, and I've got functions like, for example, my cycle time. So this is the amount of time that this PID gets executed within my CPU. So if it's a very slow loop or slow changing loop, I can actually increase this value. If I want it fast, I can take it down, but you need to keep in mind your your CPU cycle. You don't want to have it actually go more than that. There are some other variables here that you can play with, lag times, also output factors, if you want to add that. If you want to go even deeper with that, and it's in highly unlikely scenarios that we actually use that, but you can actually go here to your technology block, which you created when you created the block, and I can go to commissioning, and I can actually start the loop here, and yeah, I can play a little bit with the trend. These variables actually take over the ones from the block, and I can do my tuning in here if needs be. So just an additional section where you can actually do that if you want to. Just remember to stop it, otherwise it will prohibit your auxiliary actions from the block. And I can actually also go to my configuration, and the majority of the settings on the block is actually also laid out here if you want to have a look at it. It's also advanced parameters where it goes really deep into all the background mathematics of the PID loop, and you can do your settings here as well. I'm just going to monitor and see my current values on my block and what my initial values actually are from my data block. And that is basically it for PID loop tuning. It's usually a very high time consuming action depending on what type of loop you're handling, but hopefully this video assists with you navigating through that. That's Uruguay again, and thank you very much.